So far in our project for our embedded system, we've acquired a waveform, brought it onto our FPGA, and then streamed it up through a DMA channel up to our microprocessor. Once on our processor, we've done some analysis and logging of the information. Now, we're actually going to stream the information across the Ethernet network up to our Windows PC in order to have a user interface for our end customer. Let's look at our LabVIEW project. We're going to first expand out our embedded target, double-click on our microprocessor application that we've developed, and then bring up the block diagram to show the logic. Just to quickly review, we have two loops running on our microprocessor. First, a higher priority loop that's pulling information off of our DMA FIFO and feed it into a real-time FIFO to communicate to our lower priority loop. Within the lower priority loop, we're currently doing a log to disk, and now we're going to add network communication. In order to do that, we're going to use an NI protocol or NI developed protocol called network streams. So I'm going to navigate down to the data communication palette, network streams, to create a writer for our stream. I'm then going to write one element and then destroy the stream. I'm going to wire the blocks together with a reference wire and then designate a unique name for this stream. So in this case, I'm going to name it data/sine wave. Next, I need to assign a data type to this stream. It's going to be the same data type as our real-time FIFO. So I'll copy down our FIFO, or down the data type from our FIFO, and wire it up to the data type terminal. Next, in order to continue the correct propagation of errors, I'm going to wire in this API appropriately. Again, it's very important in headless systems to wire your errors correctly in order to establish a graceful exit for your application if an error does occur. And then finally, I'm going to wire up the sine wave data that we're going to write to our stream. So that completes the application on our embedded system. Now let's turn our focus to our Windows target to develop the logic for it. So back into our LabVIEW project, we're going to expand out the My Computer Windows target, double-click on our application developed there. You'll notice I've already created a user interface for the application, as well as drop down the reader API for our stream. So all we need to do now on our Windows host is designate the stream that we're using. Again, we named it data/sine wave. So now let's actually deploy the application. Again, we're first going to deploy our real-time application, which is compiled down for this unique target and then deployed to the target once it's compiled. Then once it's compiled and downloaded, we're actually going to then execute our Windows application to then complete the communication between our microprocessor and our Windows computer. So to summarize the embedded application that we've created, let's look back at what we've done. We've acquired a sine wave through our analog input, up through our FPGA, and then used the DMA channel to stream it up to our microprocessor, where we did analysis and logging. And then we took that information and streamed it through our Ethernet network up to our Windows PC in order to have a user interface for our end customer. Thank you for watching.